Hello everyone, my name is Nazrul Hassan Khan, third year student at a government engineering college of Samrat Ashok Technological Institute, Vidisha. To begin with, I would like to thank Emertxe Information Technology for providing me this opportunity to be a part of this IoT internship. During this internship, we built a project on IoT-based home automation solution. I would also like to thank our project guide Jay Lakshmi ma'am, my team members Dharmendra Prajapati, third year student at a Samrat Ashok Technological Institute, Vidisha. From here, my team members will explain.
Presentation. The first slide, it consists of the contents that were covered during this 1 month internship. 1 month internship were divided into 4 weeks, and in these 4 weeks, we learned various different concepts such as C programming, what is Internet of Things, embedded system, and microcontroller. We will discuss the project in following ways. First, we will discuss about the project overview. Next, we will discuss about the project objective. Next, we will discuss how we design the different elements that are required for this project. I will provide you with a real-time simulation of the project and a conclusion will be derived from the same. Next, in the first week, we learned about C programming. C programming, it is an essential tool to program for Arduino board. C it is a general purpose language and is applied and used effectively in various domains. Structure of a simple C program is as shown in the image. First, it consists of a file header. A file header consists of the name of the program. It also consists of the author name, date, etc. and other information. Preprocessor directive. Preprocessor directive tells the compiler to pre-process the information before the compilation start. The main program, it is the program which is first called by the compiler, and within these curly braces we place the body of the program. This is the comment, this is a simple printf statement, and this is the program termination. Next, what were the topics learned during this first week? Okay, we learned about the data types such as character, which is used for storing character and has a memory space of 1 byte. Next, we learned about integer, which is used for storing numbers and it has a memory space from 2 to 4 bytes. Float, which is used for storing decimal values and has memory range of 4 bytes. And double, which has a memory range of 8 bytes and is also used for storing decimal values. We also learned about modifiers and qualifiers. Modifiers such as short, long, unsigned, and signed, and qualifiers such as const and volatile. We also learned about conditionals and loops. Conditionals like if and else statement and also else if statement. Loops such as for loop, while loop, and do while loop. We also learned about arithmetic operators, bitwise operators, logical operators, etc. We also learned about arrays, which is used for storing elements with similar data types, pointers, which is used for storing the address of another variable, string, which is a sequence of characters, functions, storage class, preprocessor. We also learned about C++, which is an object-oriented programming language rather than C, which is a procedural-based programming language. We also learned about the difference between C and C++. We discussed their advantages and then we used a combination of these languages for project purpose. Next, what is Internet of Things? Internet of Things describe physical object with sensors, processing ability, software and other technologies that connect and exchange data with other devices and systems over the internet or other communications networks. Internet of Things stands for application, healthcare, automobile, logistic and transport businesses. Example, Internet of Things is used in wearable health monitors, smart cars, smart buildings, home automations, etc. Real life example of Internet of Things is Alexa, which is used for controlling TV, our home lights, and other devices. Now, what is embedded system? An embedded system is a combination of a computer hardware and software designed for a specific function. Embedded system use communication port to transmit data between the processor and peripheral devices, often other embedded system using a communication protocol. Generally, they comprise of a processor, power supply, memory, and communication ports. As you can see the embedded system structure. It consists of a sensor, an analog to digital converter, processor and ASIC memory unit, then digital to analog converter and an actuator. Next. Examples of embedded system. Examples of embedded system are CAT scanners, implanted heart monitors, electric vehicle, household appliances, mobile phones, smartwatches, iPods, signals, okay, video cameras, cars, landlines, metros, washing machines, GPS devices, etc. Microcontroller. Microcontroller consists of an analog to digital converter block and digital to analog converter block, timers and counters, pulse width modulators, processor memory and input output ports. It also consists of microprocessor and microcontroller. Thus, we learned the difference about the same of microprocessor and microcontroller. We learned about RAM, ROM, and their types. Now, project overview. This project provides an IoT-based home automation solution using Arduino Uno board in PixSimLab Stimulator. We remotely control the device using an app called Blink IoT app. We automated the garden lights where they lighten or brighten according to the sunlight. We also use an automated temperature control system. And last but not the least, water tank is automated by controlling the inlet and outlet valve. What was the objective behind this project? The objective behind this project was to connect all the discussed home appliances to Arduino Uno and integrate it with the Blink IoT app. We also obtain critical information regarding temperature and water tank on the Blink IoT app. We check the real-time status of the temperature and water level on the Blink IoT app. We also contain the garden light automatically. Next, what was the need for home automation? If we focus on our daily life schedule, there are many devices which are not monitored as we move to office, colleges, and other places. Thus, to avoid such negligence and also to protect our houses from any incident, we can use automation. We can control many home devices using automation. Few of them of which are covered in this project. As you can see in the image, this is a simple home. If we integrate it with an Arduino Uno board, Blink Cloud and Blink IoT app, we convert the same house into a smart house. Now, what is an Arduino Uno board, which we have been speaking about? Arduino Uno is a microcontroller board based on Atmega 328P. It has 14 digital input-output pins, 6 can be used as pulse width modulator, and 6 analog input-output pins. A 16 megahertz ceramic resonator. It also has a USB connection, a power jack, and a reset button. Arduino Uno board can be programmed using various IDEs, that is integrated developer environment, but we are using Arduino IDE for this project. Now, what is PixSimLab and Blink IoT app? PixSimLab, it is an open source real-time emulator. It has an integration with an Arduino IDE for programming the board's microcontroller. Blink is an IoT platform for iOS or Android smartphones that is used to control Arduino via internet. We understood how to create new template, how to add new device, how to add and select data stream, and also how to create an icon and include Blink library. Next, what is the LDR? LDR stands for light dependent resistor. These are tiny light sensing devices also known as photoresistor. An LDR is a light resistor whose resistance changes as the amount of light falling on it changes. The resistance of LDR decreases with an increase in light intensity. This property allows us to use them for making light sensing circuits. The LED lights are connected to the LDR via ADC, analog to digital converter. The analog to digital converter converts the analog input by the LDR into its equivalent digital form, which is converted later by certain formula, and it forms a range from 0 to 255 as an upper bound. Based on that, we glow the LED. Next, what are the garden control lights? The properties of the LDR sensors are applied to accomplish the controlling of garden lights. During the day, the outdoor light is maximum, so the LDR sensor detects the light and the garden light is turned off. Whereas at the night, the outdoor light is very low, so the LDR sensors detect the light and the light is turned on. As you can see in the diagram, this is the Arduino Uno board, and the LDR sensor detect the light and transfers the information to the Arduino Uno board, which in turn controls the lights. Next, temperature sensor. The temperature is recorded using an LM35 sensor, which read analog values. The value is converted into binary value, and the later actual temperature is calculated using obtained value of the voltage. This sensor does not require any external calibration to provide accuracy in the result. As you can see in the figure, this is an LM35 sensor. Moving on to the next slide, temperature control system. Temperature control system consists of a heating resistor, an LM35 temperature sensor, and a cooler. Analog value of the temperature is obtained from temperature sensor LM35, and we display it on the CLCD after converting it into digital value using analog to digital converter. We control the temperature of the system by turning on and off the heater and cooler through the Blink IoT app, which is a part of an automation. The feature of this system is that as soon as the temperature reaches 35 degrees Celsius, the heater turns off automatically to avoid more heating. The notification of the same is displayed on the terminal of the Blink IoT app. As you can see in the diagram, this is the Blink IoT app. This is the Arduino Uno board. This is CLCD and the temperature system. As you can see, the heater is and the cooler both are controlled using the Blink IoT app, and the information is passed to the Arduino Uno, which transfers the info to the temperature system, and the cooler or heater is turned on and off based on that. The temperature system pass on the information of the temperature, which is displayed on the Blink IoT app. Also, it is displayed on the CLCD, and the notification of the same is displayed on both on the CLCD, whether the heater or cooler is on or off. The same is displayed on the Blink IoT app. Moving on to the next slide, the water inlet and outlet valve control. Okay, we read the volume of the water in the water tank through serial communication and display it on the CLCD. We also control the volume of the water in tank by controlling the inlet and outlet valve by sending command through serial communication, display the volume of water in the tank on the CLCD and also on the Blink IoT app. Here, the main feature is that as soon as the tank is full, the inlet valve is turned off automatically, and when the water level in the tank is below 2000 liters, the inlet valve is turned on automatically, and the notification for same is provided on the terminal of Blink app. Okay, as you can see here, the Blink IoT app is there. This is the Arduino Uno board, water tank, and CLCD. On CLCD, we display the notification and the volume of the water tank. Same is displayed on the Blink IoT app. Okay, we control the inlet and outlet valve through the Blink IoT app. That information is passed to Arduino Uno, which transfer the information onto the water tank, and the inlet and outlet valve are then turned on and off. We provide the information of volume of the water through the water tank, which is passed to Arduino Uno, which is passed to the Blink IoT app. Moving on to the next slide. This is the simulation image of my project. As you can see over here, we display the temperature, volume, whether the heater is on or off, whether the inflow is on or off. This whole is an CLCD. This is an LDR sensor, and this is the LED. This is a Ethernet which is used for the internet connection, IoT connection of the app. This is the temperature control system which consists of an LM35 temperature sensor. This is the cooler, and it also consists of an inbuilt heater. As you can see here, this is a serial tank which is used for demonstration purpose as a water tank. This is the Arduino Uno board, and here there are connections made. And at the last slide, that is the conclusion of the project. Using the Blink IoT application and PigSim simulator, we simulated home automation where LED temperature system serial tank resembles light, heater cooler, and water tank in real time. CLCD acts like a dashboard used for displaying the events. Widgets from the Blink IoT app like button widgets are used to control the heater, cooler, and inlet valve and outlet valve. Gauge widgets to display the temperature and volume of the water. Hence, the project provides a perfect solution for home automation. Thank you. This was the PPT regarding the project. Next, we will discuss about the project code, and I will also provide a real-time simulation of the project. So this is the Arduino IDE user interface where I have written the code for home automation project. We have created separate files as they are easy to maintain, and we will look at each of them one by one. First of all, this is the home automation main file. It consists of the Blink authorization token, device name and template ID which we get when we register the device on Blink IoT cloud platform. These are some preprocessor directive which we need to include in order to use Blink as well as to use the CLCD display. This is the function for the cooler pin which we display on the Blink IoT app in order to control the cooler. This is the code for the heater pin. Similarly, these are the codes for inlet and outlet valve of the cereal tank. We also need to display the temperature on the Blink IoT app. Hence, this is the code for the same, where we display the real-time temperature reading. We need to handle the temperature, that is when it is above 35 degrees Celsius, we need to turn off the heater. We also print the notification on the Blink app with the following code. We also need to control the water volume above 2000 liters. Hence, we create a function called as handle tank. It checks if the volume of the water is less than 2000 liters, then it enables the inlet valve. If the tank is full, then the inlet valve is turned off. Now, this is the setup function which is called only one time. So we initialize the LDR, that are the guidance lights. We also initialize the CLCD display and we also print information on it. Then we call the temperature system and we also initialize the serial tank in the setup. Next, this is the loop function which call all of these functions written in it repeatedly. Moving on to the next file. This is the garden light file. It consists of a function of initializing the garden lights and it also consists of a function to control the brightness. When there is a daylight, the LEDs are turned off, and when the brightness is low, that is when it is evening and night time, the brightness of the LEDs increases. This is the LDR header file where we define some macros for the LDR sensor as well as for the garden light pin. This is the main header file where we define macros for on and off. We also define macros for the inlet outlet pins, cooler and heater pins, water volume gauge, blink, terminal pin, and temperature gauge. Next, the serial tank file. The serial tank file consists of a function of initializing the serial tank. Then we define a volume function to get the real-time status of the volume of the tank. We define a function to enable and disable inlet and outlet valve respectively. This is the serial tank header file. It consists of the inlet and outlet valve macros defined, also macros for high float and low float for volume to enable and disable. This file is for the temperature system. We initialize the temperature system. We read the temperature from the temperature system using this function. This is the cooler control and heater control function respectively. At last, this is the temperature system header file where it consists of the macros for heater and cooler pins where they are connected to the Arduino Uno board, and also for the temperature sensor a macro is defined. So this is the PixSimLab user interface. If we are in the spare parts window where we have arranged CLCD display, as you can see it is displaying the temperature as 27.34, which is the normal room temperature. The volume of the cereal tank, which is currently 3000, that is the tank is full and the inflow is off. This is the LDR system. These are the LEDs, garden lights. This is the Ethernet used for internet connection of the Arduino Uno board. And this is the temperature control system. It has the inbuilt LM35 sensor. This is the cooler and it has an heater. This is the Arduino Uno board through which these different spare parts are connected. This is the serial tank which is connected currently to the serial port COM2, and as you can see it is currently full and the inflow is off. This is the outflow. Next I will mirror my phone to the system and we will control this home different home components using the mobile phone and Blink IoT app. So as you can see, now I have mirrored my phone. This is the Blink IoT app user interface. This is the cooler pin, heater pin, real-time temperature reading. This is the notification terminal. There are two tabs, tab 1 and tab 2 respectively. Tab 1 is for the temperature system. Tab 2 is for the inlet and outlet valve, that is for the serial water tank. Here the volume of the water tank, that is what is the current volume, is displayed. As you can see, it is currently 3000 liters. So first we will try to control the temperature system. We will turn on the heater and check if the temperature reaches 35 degrees Celsius, whether the heater is getting turned off automatically or not, and whether we are receiving the notification for the same or not. So as you can see, the temperature is increasing. As soon as the temperature reaches 35 degrees Celsius, we receive the notification that the temperature is at above 35 degrees Celsius and turning off the heater. Now we will turn on the cooler. When we turn on the cooler, the temperature decreases and the fan starts rotating and it tries to maintain the normal room temperature. We will turn on the cooler now. Next, we will check the cereal tank. So as you can see, the cereal tank currently it is full and the inflow is off. We will try to turn on the outflow and check if the level is less than 2000, whether the outflow is getting on or off. As you can see, the outflow is on now. Notification for the same is displayed on CLCD and the water level is also decreasing. When the water level is less than 2000, the inlet valve is turned on automatically and it tries to maintain that water level. We will turn on the outlet valve and the inlet valve will now fill the tank, and when it reaches 3000 liters, it will turn off automatically. As you can see, the inlet valve turned off automatically. We will check our notifications. As you can see, when the water level was less than 2000, we received the notification and it turned on the inlet valve. When the tank is full, we also received the notification and it turned off the inlet valve. Now the last system, that is the garden lights. This is the LDR sensor. When the sunlight is maximum, when the sunlight is maximum, the garden lights are off, and when it is nearly evening or night, then the garden lights are brightest. That is the light are turned on automatically. So this was the home automation project.